Hi, this is Sangram Redkar again, and I'm gonna talk about the second part of this lesson. We are going to talk about Symbolic Toolbox. And thank you for subscribing to my channel. Now there are quite a few subscribers. I'm glad to see that you are interested in viewing the material. Okay, so let me start with this. If I have a variable a is equal to 1, it simply assigns the value of a is equal to 1. Now, if I have another variable, just say t, it says it is an undefined function or variable t. So in the previous case over here, we assigned certain value to a. So as soon as MATLAB encountered this a, it substituted that a for this value 1. However, MATLAB at this point does not know what is this value t. So it's actually undefined. Now sometimes you have to do a symbolic manipulation, which means this t needs to remain as t. So t doesn't have to be equal to 1, 2, 3 or 4. So what we want to do is this t has to stay as t, and we should be able to find out what is the value of, say, cosine t, what is the value of integration or differentiation of, say, t square or t cube, and so on. So what we want to do is we want to create a symbolic variable, which means MATLAB would treat this t not as a numeric value but a symbolic variable itself. So the way we start that is I say syms space t. So now what MATLAB did, it created a symbolic variable t, and observe this a is equal to 1. Value of a is defined as 1, but value of t, MATLAB simply states it is a 1 by 1 symbolic object. So what it means, it's perfectly fine if I were to say cosine of t. So MATLAB got it. So it said it's a cosine function, and the argument or the variable that it's operating on is t. So what I could do is I could differentiate or integrate this particular function. Say for an example, as I go on, I just say here diff, that stands for differentiation, diff, and I say diff, I would say function. The function is cosine of t, and then what I want to do is I want MATLAB to know how many derivatives am I looking at. Do I want to take just one derivative, or do I want to take two derivatives? So what is the order of differentiation? And then I need to specify the variable, and I'm gonna say 1. So what is the differentiation of cosine t? As we know, it's minus sine t. So let's see, here we go. MATLAB said the answer is minus sine t. Just for the practice, I'm gonna say diff of sine, again t in the bracket. T is the variable that we want to differentiate with, and I say 1, and it became cosine t. So MATLAB actually does not know what the value of t, but it performed a symbolic manipulation, a symbolic operation on this function. So again, MATLAB would allow us to use different mathematical operations. For an example, say integration. So for function, the integration function, we say int, and int again I would say cosine of t, and then again, as you can see, let me pull this window a little bit up here. As you can see, as soon as MATLAB, I type in int, MATLAB would give me a help. It would say, okay, how to use this function. This is the way this function can be used. Now, next thing is I could do a definite integral, or I could do an indefinite integral, which means I can specify the limits or I don't specify the limits. So what I would do is I would just say comma, I would say t, and then here it is, integration of cosine t, as we know it's sine t. Watch out here though, differentiation of cosine t is minus sine t, but integration of cosine t is sine t. Isn't that cool? Now what we can do is we can actually use some other functions, like we can use symbolic manipulation to find limits. So it would give us the value of the limit. So what is the limiting value? We can use symbolic operation to find out, I don't know, maybe what is the inverse Laplace transform. We can use the symbolic manipulation to find out, say, the Taylor series expansion. So let's see, let me try this. So what I'm going to say is I want to find out the Taylor series expansion. Taylor series expansion is an approximation of the function. So let's see, Taylor series, Taylor, I would say sine, and I want you to observe this. As soon as I type in Taylor, it gives me the help. So Taylor can be used multiple ways. So let's try this for a second. I'm gonna say Taylor sine t, and let's see what happens. Oh, here we got an approximate expression for Taylor series of sine t. Now just observe, as we know, sometimes we substitute sine t is equal to t. This approximation is perfectly fine for small values of t. As the values of t increase, we need to include these higher order terms. So this, what we see here, is the Taylor series expansion of this function sine t. You can try that again with a cosine function, say cosine of t, and then I say this is what is the cosine function. So observe, for small values of cosine, say if your cosine values are say 0 or 0.1, your approximation is gonna be equal to 1. So that's what it says. Say if your cosine value is 0, your value, the answer would be 1. If your cosine values are between plus and minus 20 degrees, then I guess you will have to include the different values of t. So your approximation would be the approximation I have highlighted over here. And as we go through this, there are some cool interesting applications. Like what you could do is you could have a function that is totally defined in terms of symbolic variable. Say let me say f is equal to, I'm gonna say t square, okay, plus t cube. Now as enter, MATLAB without any complaint, it said f is equal to t square and t cube. I could actually integrate this function, I could differentiate this function, and if I want to, I can use this function multiple ways. And but say here is the case. What I want to do is I want to find out a particular value of t. Say for an example, I want to find out what is the value of f when the value of t is say 3. And for that I would have to use the substitution. So what I need to do is I need to evaluate value of t, evaluate value of f when I supply the value of t. And we would talk about this more in the class, but symbolic calculation is very useful. It can be used in multiple ways, and you can do lot of manipulation and perform mathematical operations with a MATLAB symbolic object. Thank you.